Thank you very much. It's an honor to be here. It's a particular honor to be introduced by the award winner of the day. Thank you very much, Dr. Leonard, for your introduction. And I also have to say thank you to Dr. Sayre for inviting me here to share some of my science with you. I have been in the field of really, I used to say schizophrenia, but now I say psychosis for quite a while. And I've got a bit of data to show you today, and I'm excited to get to it. I have to say first that I'm very delighted at your hospitality. Of course, I walked into the lunch today and thought it was lunch for 2,000. And it was a wonderful experience being able to taste many different things, so but I still have to remember that I have to keep my thoughts organized in order to present the story to you today. I'm delighted to be able to present this story. Translational neuroscience is extremely important, and our field has been frustrated lately, maybe over the last 5 or 6 years, with major pharmaceutical companies closing down their the psychiatric drug development programs and many different failures in the field. I've been working with a group for the last 10, probably 12 years, called the Bipolar and Schizophrenia Network for Intermediate Phenotypes. And that's a very long name for what I'll just call BSNP from now on. So BSNP is a consortium of people that's supported by the NIH, and we do science between the areas of psychotic bipolar and schizophrenia. And I'll give you the rationale in just a minute. I want to tell you, before I tell you what we found, I want to tell you a little bit about who we are, what we have done, and then what I would like to even pose as a question is, where do we go next? Because we're at a crossroads, and it may be that one of you has a very interesting idea. So let me tell you first who we are. We're 6 different sites in the United States, and I have them listed in bold on the left: Athens, Georgia, Boston, Massachusetts, Chicago, Dallas, which is my site, Cincinnati, and Hartford. And all the PIs at those sites have their names underlined, just in case you may know any people at these sites and some other people associated with it. You can see from this that we're really a big group. We became accidentally this big, but we are a big group anyway, showing that it really sometimes takes a village to do a simple task. These are the people across the top: Godfrey Perlson, Brett Clements, myself, Macheri Keshavan, and Elliot Gershon are the PIs. And then we have a whole host of other people, only a fraction of whom's pictures, the prettiest pictures really, they're almost all women, that I put up here along with the PIs. Now let me tell you, this BSNP group, the BSNP consortium, came together over a problem. We had a model. We had a first model of what we were thinking of. Instead of just studying schizophrenia, we thought, why don't we put together some different psychosis diagnoses? So we had psychotic bipolar disorder, schizophrenia, and then in between this schizoaffective disorder. Now, we were thinking of this in a very traditional way, that schizophrenia is a disease, bipolar disorder is a disease, schizoaffective disorder is a disease. There was some gray area in between, some crossover area we admitted, and what we were going to do was study the dimension of psychosis, recognizing that there are other dimensions also. We were going to look at psychosis. We had the idea that we were going to measure intermediate phenotypes. These are things that people call biomarkers, maybe bioindicators. And we had the hypothesis, as many people did, that these intermediate phenotypes are closely associated with genes, and that we could more easily associate genes with these intermediate phenotypes, and then these intermediate phenotypes with the diagnoses. So as a physician, I was always frustrated that a patient with some set of complaints could walk into a neurologist's office. The neurologist would spend 5 minutes and then send them off for 2 weeks of tests, and then call them back in again after those tests and give them a diagnosis. We didn't have any tests to do. We just sat and talked to people for an hour and then gave them a diagnosis. So what we were really trying to do is to connect some of these intermediate phenotypes with some of these diagnoses, these serious mental illness diagnoses, so that we could be more physicianly. We could actually do tests and make diagnoses based on the tests. Now, even though I still like this figure, because I think it's balanced and it's quite logical, the figure is really all wrong. But I thought I would tell you where we started, and you can see where we'll end up, and we end up in a very different place than we started. Nonetheless, we started out with the idea that we would do psychosis phenotyping. And we developed first a tool to do this phenotyping with. And this tool, we first would assess clinical characteristics the way we always did, demographics, family, physical and mental history, family history. We would get an idea of medications, lifetime psychosis history. We did, for our structured diagnosis, we did the SCID, and then we did some symptom rating scales, and symptoms rating scales, the Birchwood social function scale, and some other scales here. These are all clinical scales. What we did, which was a little unique, is we did a whole battery of neurobiological characteristics. We looked at cognition. We did the BACS, but in addition to that, we had other both electronic and cognitive and oral assessments of cognition. We did a very broad neurophysiological assessment. We looked at eye tracking, which all of you know is oftentimes abnormal in psychotic conditions, especially saccadic eye movements. We did EEG. We did both evoked potential and resting state EEG, so we got lots of different measures. We did steady state auditory, steady state visual, and then we did an emotional ERP task. We also looked at brain imaging parameters. Mostly we assessed structure, VBM, and we did a VBM analysis also, and then we did resting state fMRI, DTI, and ASL. These are the imaging parameters that can rather easily be done across sites. It's much more difficult to do regular functional bold studies across sites, so we didn't do any of that. We collected blood for DNA, serum, and plasma. And also what I don't have on here, but that I'll tell you a little bit about at the end, is that in some of these people we collected dermal biopsies so that we could make stem cells. Now this battery was, when we started out, it was a bit of a theoretical battery, but I can tell you that we've used really all of these parameters. Our consortium is characterized by each one of the 6 sites that you saw having a distinct reputation and talent at doing some of these different analyses. So that we had one of the sites that was an expert site at doing these kind of analyses. So in the first, let me just show you again what the numbers are. Between the 5 sites in the first phase of this, we call it BSNP1 because we're on to BSNP2 and perhaps on to BSNP3. We collected about 1,000 probands. For each one of the probands, we had at least one relative, and we had about 500 healthy controls. It sounds like a lot, and it gave some power to the data analysis, which I'll show you in a minute we really needed. Here is some example of the data that we collected. Some of the Birchwood social function scale, EEG, various EEG parameters, imaging parameters, resting state, fMRI parameters. I won't go into this. I could spend hours telling you all the different things that we found. But let me tell you what was the bottom line, which was really quite disappointing to all of us. We had about perhaps 70 or 80 different biomarkers. And I told you from the beginning that we were looking for biomarkers that fell on diagnoses. Well, you would think we would at least find a couple, but we didn't. We didn't find any distinctive biomarker that fell on any one of our diagnoses strongly enough to be a diagnostic biomarker for that, for the diagnosis. This was fairly disappointing to all of us because we had to really face the reality that the diseases we had spent decades defining probably were not biologically based, since we really addressed all of the biologic markers that we could, that there was any indication to suggest, to include. So the bottom line, when we got down to looking at this carefully, first was that there were very many associations between psychosis and this battery. We published many papers, we made many observations about the relationship between EEG and psychosis and imaging and psychosis. It was very powerful. It was very important for us to have such large numbers, because we could look at everything by the total psychosis group, which was by dimension, and then we could look at things by diagnoses. What I can say in general about these biomarkers is that people with a diagnosis of schizophrenia were usually more severely affected, but they were not different in kind than schizoaffective disorder or psychotic bipolar disorder. There was no distinctive single biomarker, nor even a battery, a fingerprint, a battery of biomarkers. Schizophrenia and schizoaffective disorder were most often the same. I can't tell you how each one of us sat through these diagnostic conferences. You probably have yourself, and struggling, should this be schizoaffective? Should this be schizophrenia with some depression? Well, it turns out from a biologic point of view that it just doesn't make any difference at all. From a biologic point of view, there may be other things associated with it. Psychotic bipolar throughout showed schizophrenia-like phenotypes, except for one thing, and that was psychotic bipolar people had nearly normal brain volume, whereas people with schizophrenia, as you know, have reduced volume. This was somewhat confounded by people with psychotic bipolar oftentimes having lithium, either current lithium or lithium in the past, and as you know, lithium affects neocortical volume, so that we had to face that this single difference that we found may have just been a drug side effect. It was very important, and I've said this before in all of this work, that it was the battery that was important. Oftentimes, and all of us who are now working together in BSNP had previously worked together with just one biomarker because that's what we could do. I personally did brain imaging, and Brett Clements did electrophysiology, and we never had put them all together now. It's a bit difficult for 5 strong-minded people to work together. You can imagine the discussions and the disagreements and the rare moments of agreement that we have, but it's been worthwhile. But we had to face the bottom line, which I've bolded in yellow. There were no biomarkers which reliably distinguished DSM diagnoses. Now, in the United States, how we get funded for our research through the NIMH is submitting very interesting grants. And the first grant that we submitted for BSNP1, people thought would be interesting because we could find genes associated with biomarkers. I'll show you how successful that was in a minute. It wasn't very successful. This time we were right at the edge. We had pulled together all of our data because we were ready to submit our second submission for a grant. So we couldn't go to NIMH and say we've done this very big study. We had superb reliability across 6 different sites. We generated a huge amount of data, and we found nothing. That wouldn't really be strong enough in the United States for a grant. So we had to pull together another story. So let me show you what we did. We took these 50 or so, there are more like 70 biomarkers, and we looked at which biomarkers interacted with each other, because we didn't want to take all 50 of these because some of them were measuring the similar sorts of constructs. So we got together these 9 bioindicators, as we'll call them, and these are mostly independently behaving biomarkers of what we saw of psychosis and of people with had psychosis. And there were 3 biomarkers that we could group together under a column called cognitive control. These are all cognition-driven tasks: the BACS, the stop signal task, the anti-saccade error. And there were then 6 different bioindicators that were all built on electrophysiology and eye tracking. And these we could put together under what we would call sensory motor reactivity. So what we did, just to see where did biology, we knew that phenomenology could help us divide our psychoses into schizophrenia, schizoaffective, psychotic, bipolar. But if we took those diagnoses off, could the biology help us group together? So we stripped off the DSM diagnoses from everybody. We put everybody into the statistical analysis, and I'm not the mathematician or the statistician, but it's really interesting to watch them work. And we found that, in fact, if we considered all of them, the whole battery of biomarkers, we found 3 was the lowest group that we found, and we called these groups biotypes. We figured that was better than putting our name on them all, so we just called them biotype 1, 2, and 3. So for probands, biotype 1, 2, and 3 all had different levels of cognition. They had different levels of sensory motor reactivity. Rather than explain these numbers to you, I'll show you our cartoon. So what we did, we started out with schizophrenia, schizoaffective disorder, and psychotic bipolar disorder. With those 3 groups, we found that there were really no major differences, that we could not find critical biological differences between these groups. We were looking for biological differences, not phenomenology. So we put them all together into one group we called psychosis. We used a prism where we looked at cognition and where we looked at sensory motor reactivity. And I'll show you more of these kinds of plots in a minute. And the calculations spread these people with psychosis into 3 different groups. Now, this is a cartoon, so I took the liberty of putting all the blues here, all the reds here, and all the greens here. But you must have to understand that there's still variability between these groups. And if we had to make a guess, we would not say that these are all the groups that there are in psychosis. We're expecting that there will be subgroups. There would be subgroups of each of these. So there was one group we called biotype 1, which in our hands was the worst group. No, I should say, really, if you looked at the level of psychosis, the level of positive psychotic symptoms was more or less the same across all groups, slightly lower in biotype 3. Biotype 1 had significantly greater negative symptoms, and these people had the worst illness. They had the most recurrences, they had the most relapses, they'd spent the longest time as inpatients in hospitals. And this group, biotype 1, had the most number of relatives with psychotic illness, with either schizotypal diagnoses or psychotic diagnoses. The biotype 2 group was somewhere in the middle, and I'll get into cognition and EEG in a minute. The biotype 3 group was probably the one that we struggled with most, thinking what was distinctive about it, because in fact the biotype 3 group had almost normal cognition, slightly lower, but almost normal cognition, and they had almost normal EEG, whether you would look at resting state EEG or whether you would look at evoked potential. So this group was a kind of a curious group. Because although they were as psychotic as the rest of everybody else, their cognition was least impacted and their EEG was least impacted. So people said, I wonder what could those be? And so one of the guys spoke up, those must be the potheads. So then we did an analysis about how many early cannabis users there were in each of these groups, and in fact 90% of the biotype 3 were cannabis users, and a good number were early cannabis users. So we made this the green group, just to help us not forget that in fact this could be what we would then call an environmental group, people who wouldn't have otherwise gotten something that we would diagnose as schizophrenia or psychotic bipolar except for an environmental event. This biotype 1 is a group that had very low EEG. They had very low resting state. If this is almost normal, you can see that the resting state of these, just an illustrative resting state is very low, and the illustrative evoked potential, and I'll show you more of these data, is very low. These had the relatives with, so we figured this would be close to a genetic group, although we weren't quite right on that either. And these group of this biotype 1 had the most neocortical volume loss of any of the groups. Biotype 3 had almost no cortical volume loss. I should start in another place. This group, biotype 1, had diffuse neocortical and subcortical volume loss. Biotype 2, the group had mainly frontotemporal volume loss, although it was somewhat more distributed. These people had only slight volume loss, and it was really fairly reliably restricted to the limbic system. Biotype 2 was very interesting also because instead of having low EEG, it had high EEG, higher than normal, both the resting state and the evoked potential. So we had these psychosis groups with very different EEG profiles and very different cognitive profiles. Let me show you how the diagnoses distributed themselves across, this is biotype 1, this is biotype 2, and this is biotype 3. So the orange dots are diagnoses of schizophrenia. So there's a slight preponderance of people with schizophrenia in biotype 1, but there's a good distribution all across. There's a preponderance of psychotic bipolars in biotype 3, but they're all distributed all along, and then the schizoaffective people are located in between. And here are what I would call, what I have described as the characteristics then of the BSNP biotype 1, biotype 2, and biotype 3. With the BSNP 1s having very low cognition. I meant to say that before. They had the very lowest cognition numbers. They had very low, abnormally low EEG power and abnormally low gray matter volume reduction. They had the worst negative symptoms, the highest number of affected relatives. The polygene score I'll get to in just a minute, and they had the lowest cannabis use. These people had spent significantly more time in the hospital, so they could have had a decreased cannabis use just because they were not around it in any way. The BSNP biotype 2s had low cognition, but not as low as biotype 1s. Instead of having low EEG power, they had high EEG power. They had low but focused cortical volume. And they also had some affected relatives and with moderate cannabis use. This was the high cannabis use group with nearly normal cognition, slightly low on EEG power, but really quite normal. And they had the lowest percent. They had really next to normal affected relatives. So we then could say to our grant committee, we took your money the first time and we did some very clever things with it. And we think that from a biologic perspective, what we would like to do further is to study this more, and we would like to replicate it. So we were awarded then, just because of the replication question, a second study period, which we're about in the middle of now, and I'd like to even tell you what we're doing. So we did some GWAS studies on our first group of people. Our first group of probands, there were 936 probands, and some of those couldn't be used because we only looked at, we had to look at the probands by race. So we had probably 600 probands that we put into an analysis looking for genes for biomarkers, but also looking for a genetic fingerprint for the biotypes. We really found neither one of them, but we did find one association that was significant, which was association between neurorexin and one of the and the anterior volume of the anterior volume of the part of the CSF that abuts the hippocampus. an increased volume. So it was suggesting that perhaps the hippocampus or some medial temporal lobe structure may be particularly reduced. Remembering that it took us 35,000 people with the diagnosis of schizophrenia and 45,000 normal controls, we weren't really expecting that we were going to see what we wanted to with this analysis. But we'll keep going. With BSNP2, we have up to probably 3,000 cases now, so we'll be able to continue on with this. We did another thing with another kind of analysis with these data that I thought was interesting. This is our statistician in all of this is Robert Gibbons. He's at the University of Chicago, and one of his favorite analytic techniques is something which he calls multiple item response theory. And what we did was we took all of the clinical items that we had rated from the PANS, the MADRS, and the YMRS, and we wanted to see where abnormalities in these rating scales, where they located on the brain. Our null hypothesis was that each one of these, that we wouldn't really find anything, that what we would find are scattered associations between any one of these regions and any, on the free surfer analysis, any neocortical region. But instead what we found was a very interesting thing. We found that all of the psychosis ratings that I showed you before fell significantly on a group of regions that were all clustered together, and they were clustered together over the temporal frontal, a little bit into the parietal lobe, and each one of these then in some way correlated with what we drew out of these as psychotic symptoms. So it would suggest really that this region could be really powerfully important for the construct of psychosis. We have more to do, and we have more people now, so we can repeat this analysis into the future. So when we first tried to publish these data, although we did in the American Journal, the editor said, well, you need a replication. You know how tough it is these days to replicate stuff, and you need a replication. And we nearly fainted. You know, it took us 5 years and 5 sites and $25 million to make the first finding. At least we need to publish it before we can do the replication. So finally, the American Journal relented, and we put a lot of caveats in about these not being replicated data, so that we knew when we did the second, when we did our second study, BSNP2, when we did our second study, replication had to be right on the top of the list of what we were going to do. And then we also knew that we had to demonstrate that there was some stability to the phenotype. So we took a few of the people and we looked at them over time, not across differences in clinical conditions, but just over time in order to look at the stability of the biomarker itself. We wanted to do a genetic fingerprint. I just showed you where we are, and that's where we are right now, but we're pushing on further. And then we mostly wanted to do in BSNP3, we want to see if we can put these biomarkers to work. At first, we went to NIMH and said we'd like to refine these biotypes a little further. We'd like to do a little bit more phenotyping. We would like to pull in a few more cases, maybe some autism cases, maybe some psychotic depression cases. And the response from the people running the NIMH was, well, we think you've fussed with this long enough. You have to show us that this is going to tell us something important. So we have some ideas about what to do going forward, both for treatment responses. We're hoping really to use these in some ways to define pathophysiology, just like we're always heading to do. That would truly be a game changer, but we're not unrealistic and know that this is going to be a hard thing to do. But I'd like to show you a little bit of what we've done in all of these areas. The first is the replication. This was another thing we were astonished by. it was really an almost perfect replication. We were really shocked. We were hoping just for mostly a little bit of replication. These are the data from BSNP1. These are the data from BSNP2. This is the same list of biomarkers that we use to make those biofactors that we use in the creation of the biotypes. So you can see that there's, between the first time we did BSNP1 and then when we had half of BSNP2 left, so there's about 1,000 people, 1,000 probands here. Here we have about 1,500 probands, and you can see the level of congruence, a few little blips here and there, but the level of congruence between what we found in BSNP1 and BSNP2 is very close. Let me show it to you a little bit. Here again, these are the 9 different biofactors that we use to make up the biotypes in BSNP1, and you can see what they look like here. I'm just going to point out that the healthy controls, this is biotype 1, biotype 2, and biotype 3 is in green, and then this purple line is the healthy controls. And if you can see, these are the cognition biofactors, and here in BSNP2 these are the cognition biofactors, and you can see that they're of almost the same magnitude and they have the same relationship to each other. These are the EEG markers, the EEG factors in BSNP1, and these are the EEG factors in BSNP2. A little bit different in that the curves have a few more squiggles in them, right? This has a few more squiggles, this is a smoother curve, but for the main, in looking at these, they're quite similar. And this is the combined, the average of all of the 9 factors, combining BSNP1 and the first half of BSNP2. And we've been able to define then the red as biotype 1. We've been able to refine the red as biotype 1, blue as biotype 2, and green as biotype 3. We've been able to refine these factors so that we can feel more confident now about doing experiments with them. And this is another way of plotting the sensory motor reactivity against the cognitive control that I showed you. That I showed you in that cartoon. And this is what we got in biotype 1, and this is what we got in biotype 2. Perhaps biotype 2 has a little bit more refinement actually for on these biologic parameters. So this is really what the combination of psychosis, schizoaffective disorder, and psychotic bipolar disorder look like, and how similar or dissimilar they look like on measures of biology, of brain biology. Of course, we can't do a lot of the best measures that we would like to do. You know, people studying the liver can just take a little sample of the liver. People studying the skin certainly can take a little bit of skin. We have to do it in more indirect ways. But at least we were able to replicate between BSNP1 and 2 these entities we call biotypes, which gives us more confidence that we can really look at these biotypes and that they may be enduring entities. We have to demonstrate now that these are important entities. We haven't demonstrated that yet. Here's what biotype 1s look like in their EEG. This is a DSM. On the left is DSM, so I won't show that to you as much as on the right. You can see that biotype 1 in red has a very blunted ERP response, and that's its most distinctive characteristic. In the combination of BSNP1 and BSNP2, this is the most distinctive characteristic of biotype 1. Of biotype 2, the most distinctive characteristic, once we notice that there's no difference between the DSM diagnoses and healthy, if we look at biotype 1, 2, and 3, we can see that biotype 2 is the one that has the highest and the most distinct from normal EEG, whereas if we look at biotype 1, we can see it's clearly reduced from normal. And this just shows that same kind of thing in a different kind of way. It shows that there's a double dissociation between EEG and intrinsic activity and between the biotype 1 and 2s. Then if we go through the same exercise of listing out what are the characteristics of biotype 1 and biotype 2 after we do the combination analysis, in addition to all those things I said before, biotype 1 has poor attention, some focus on conceptual disorientation, hallucinations, and lack of spontaneity, high negative symptoms, clearly. And biotype 2 has a more moderately low cognition, but still low cognition, low cortical volume in frontotemporal regions, in the limbic regions. They have some episodes of a decreased sleep, unusual thought content, and stereotype thinking. And biotype 2s have an increase in anxiety, which probably wouldn't be surprising looking at EEGs that look like that. So what are the lessons now that we took away from this kind of analysis? It was a totally exploratory analysis as we started from the beginning. We didn't really start it as being an exploratory analysis, but it turned into that when the answer to our first question was no. It was very, very important that we had large sample sizes, because the large sample sizes meant that we could really work with the data a little bit to find groups that would compose it. We couldn't have done this with any low ends. Prior to this kind of study, I did kind of studies where if I got an N of 20, I would think I was really, really great. Now I look at an N and see an N of 200 and think, oh, that's a little low. So you get spoiled if you have these large sample sizes, and we could only do, of course, large sample sizes because we had a consortium. We had multi-level and this extensive biomarker panel, which I went over with you in detail. We had a sophistication of quantification, so we have mathematicians involved in this who don't know about the illness and don't know about the diseases and don't really want to know. The tools that they have is, how can you look at a big set of data and bring out clinical data that are important clinically from that. And also we had multiple people with multiple areas of expertise. And we've done lots of different kinds of analyses of these data. So what do we do next? If any of you have, I'll tell you what ideas we've had, and I would love to hear from any of you about what you would do next. The NIMH clearly wants us to just stop fussing around and getting more biomarkers. They want us to just put this to work. Does this predict treatment? Does this predict outcome to some kinds of special, does this predict who's going to get better in early psychosis? How can we use all of these data as physicians to tell families when they have questions, to tell people when they have questions? So this is what we thought of. One of the first ideas that we had was to really do a study that would predict drug response. Now, one of the pieces of data I haven't showed you yet is that because we had 900 or so people. Let me tell you something about the medication of these 900 probands first. We had psychotic bipolar disorder, schizophrenia, schizoaffective disorder. So we figured that people with schizophrenia would be extensively treated with antipsychotics. The psychotic bipolars would be extensively treated with mood stabilizers, and the people in between would be extensively treated with both of those together. No, we didn't find anything like that. We found that everybody was on everything. Now, I don't know how it is here in Turkey. In the United States, a person with serious mental illness will see a series of doctors, perhaps, and every doctor they see will add on a new medication, and nobody will take any medication away. So that if you look at people when they're 20 years into their, maybe between 10 and 20, these were mid-course schizophrenics, so they had their illness between probably 10 and 20 years. If you look at them, the average medication they were on were 4.3 medications apiece, and there were many people on six different medicines. It was really shocking. But at least it gave us a lot of data. And there were some people on mood stabilizers, there were some people on individual mood stabilizers, there were some people on different kinds of antipsychotics. And the antipsychotic that turned out to be the most interesting is when we compared people on clozapine and people not on clozapine. So of course they were on all the rest of the things they were on. This wasn't a pure study in any way, because it was just, in fact, it was a naturalistic study. But at least this particular study, and I'll show you the data in a second, is based on our observation that we could show that clozapine was associated with elevated intrinsic activity. So of course, the rationale is, though I need to explain it to a group like this, I'm sure I don't. You know, there's a very high medical need in psychosis. We can present biologically driven psychosis biotypes and bioindicators, and we can show what the EEG-based intrinsic activity is. It turns out that this intrinsic activity this is the measure that I showed you between the main difference between biotype 1, which is very low, and biotype 2, which is very high. And we wanted to find a drug that could be associated with this basic biomarker that distinguishes 1 and 2, which is EEG-based intrinsic activity. And part of this reason is there's a very small literature about clozapine. And the ends for these studies are very, very low. They're in their mid-teens, 17, 17, and 16. But all of these 3 studies in the English literature, anyway, show that clozapine use, and for the people who respond to clozapine, the most distinctive characteristic is that they elevate their EEG. Now, these studies didn't all do the same EEG measure, and they didn't necessarily do the same EEG measures that we did, but they did show that clozapine use in one of the powers was associated with an improvement, which would be a decrease in psychotic symptoms. And this is what we had shown in our data. So all of this data that I've showed you already this morning is only cross-sectional data. We don't have any data that we've collected on people where we've made an intervention. So this data right here, these data, this shows you biotype 1 down here with a low intrinsic activity. 0 is normal intrinsic activity. People with biotype 1 have low theta values, low beta band, and low gamma band. And these are people who are off clozapine, and these are people who are on clozapine. Now, if you look at biotype 2 people, these are the biotype 2s who have elevated intrinsic activity, elevated EEG. And these people, the biotype 2s, when they're on clozapine, have a further increase, more abnormal EEG with clozapine. So the idea was that we could perhaps use clozapine as a treatment, and that treatment would normalize EEG in the B1s, and it would worsen EEG in the B2s, and we could measure that with psychosis and cognition. So we decided we would develop a protocol where we would have 2 aims. First of all, we would take a group of people like I just showed you. The first aim would be to show that clozapine over a course of 4 to 6 weeks could actually increase EEG power, intrinsic activity in all of the people. And then what we would want to do in all of the biotype 1s and biotype 2s, and then what we would do in aim 2 is to postulate that in B1 would be associated with improved psychosis. They would be the responders to clozapine. B2 would not be the responders to clozapine. Now, this is just a thought. So this is just a plan. So I don't have any data to show you except the data that I showed you right here, that in an association way, in an associative way, we can associate clozapine with a normalization of intrinsic activity in biotype 1. Now, the other thing that we're getting ready to do, I mentioned before that in addition to blood, on many of these people, in fact, out of this group, we have about 200 people who have agreed to a dermal biopsy. So we take the dermal biopsy from the person. We grow it into fibroblasts for 3 or 4 weeks. It takes about 3 or 4 weeks. Then we transform the fibroblast into stem cells. That's a process that takes 6 or 8 weeks. And then we grow these stem cells into neuronal progenitor cells. And you can get neuronal progenitor cells in a dish, just loose in a dish, or you can get them to form into rosettes. Or you can get what's called organoids. These are what are called cerebral organoids, And in a way, they look like little brains. They're not at all. But they're clusters of cells that can show you the relationships of cells to each other. These show you a little bit about what the fibroblasts look like, what the stem cells look like, and then what the cerebral organoids might look like. You've read a lot about that in the newspaper, I'm sure. These are some of the cells that we have growing in our laboratory now, what the fibroblasts look like, what the stem cells look like. And these stem cells are pluripotent. You can take cells like this and you can turn them into heart tissue, you can turn them into neurons. You can, here you can see where we're really trying to turn them into these blue-like structures. You can turn the neurons into specialized neurons. You can get them, you can coax them into being dopamine neurons, coax them into being other kinds of neurons. And then if you look at these kinds of cells in the organoids, you can understand the relationships of the cells to each other. They're really synapses that form in single cell cultures, in single layer cultures, and there are synapses that form in the organoids, so you can really study them. You can study things like adhesion and migration. Are there any growth differences? Cellular morphology, are the cells bigger or little? You can study electrophysiology. Really, these cells are electrophysiologically active, and you can study synaptic plasticity at the synapses, all of which we're really interested in. And the reason that we're interested in these is because we have 3 different clusters now of cells. We have clusters of neurons. We would hope different. These are induced neurons from biotype 1, from biotype 2, and from biotype 3. And we would like to know whether there's any cellular growth differences, whether there's differences in cell shape, cell activity, and also drug responsive cells. Now, before maybe 2 or 3 years ago, I was very incredulous. The idea that you could take cells from the skin and from an individual, and you could do pharmacology on those cells. You could say what corrects a defect in those cells, and then you could tell something about the person. I would have just said, oh, that's impossible. But then Fred Gage and his group in California actually showed with lithium and with people with bipolar disorder that you can take an abnormal signal of some sort. The signal that he uses is a very, very, very complex multi something or other EEG signal, but he takes those cells and he normalizes those cells with lithium, and then some of the cells don't normalize, and he just they have no change in their EEG pattern, in their complex EEG picture at all. And then he's been able to show that the cells from these people are from people with lithium responsive bipolar disorder, and the cells associated with these people are lithium non-responsive. So that's it. It's been a striking finding, and he's extended that finding even now. So it gives us some hope, really, that we could have a tool with just a skin biopsy, and it takes really 8 or 10 months to get those cells into a situation where you can test them and where they're informative. But the idea of who responds to clozapine, is Depakote good for everybody, would really be questions we could ask from these kinds of cells. I don't have any data for you yet, but it's harder. It's almost more work to take care of these cells than it is to take care of the people that the cells come from. They're very fussy. This gives us the hope, really, that personalized medicine is what we may be able to do, and we may be able to look at cells and get some idea of what to treat somebody with, what to tell parents and families. And I don't want to be too hopeful about this because it still sounds a little bit like pie in the sky. It is pie in the sky, that's for sure. With that, I'll just say that we think that BSNP is charting new directions in psychosis understanding and treatment, and I kind of told you the story about it, and I'd like to thank you very much for listening.